Well, we've seen some examples of supervised learning, specifically regression and classification. What about unsupervised learning? In unsupervised learning techniques, you don't have a known label with which to train the model. But you can still use an algorithm that finds similarities in the data observations in order to group them into clusters. Suppose, for example, Rosie wants to segment her customers. She could cluster them based on similar characteristics, such as age, gender, the amount they spend, how regularly they buy lemonade, and so on. There are a number of ways that we can create a clustering model, and we're going to look at one of the most common and popular techniques for clustering, k-means clustering. Now, the key to understanding k-means is to remember that our data consists of rows of observations, and each row has multiple features. If we assume that each feature is a numeric value, then we can plot them as coordinates. Here, we're plotting two features on a two-dimensional grid. In reality, you would have multiple features, and you would plot them in n-dimensional space. Next, we decide how many clusters we want to create, and we call this k. And we plot k points at random locations to represent the center points of our clusters. In this case, k is 3, so we're creating 3 clusters. Next, we identify which of the 3 centroids each point is closest to, and assign the points to clusters accordingly. Then we move each centroid to the true center of the points in its cluster, and reallocate the points to the clusters based on their nearest centroid. And we just repeat that process until we have nicely separated clusters. Now let's talk about how we can measure how good a set of clusters is. We want a set of clusters that separate the data by the greatest extent possible. We can compare the average distance between the cluster centers and the average distance between the cluster centers and the points in their cluster. Cluster sets that maximize this ratio have the greatest separation. We can also use the average distance between the clusters and the maximum distance between the points and the centroid of the cluster. Another way we can evaluate the results of a clustering algorithm is to use a method called principal component analysis, or PCA, in which we decompose the points in the cluster into directions. We can represent the first 2 components of the PCA decomposition as an ellipse. The first principal component is the direction along the maximum variance, or major axis of the ellipse, and the second is along the minor axis of the ellipse. If we decompose another cluster that's perfectly separate from the first cluster, we would get an ellipse with the major axis of the ellipse perpendicular to the first cluster. If our second cluster is reasonably well, but not perfectly separated, we'll have a second ellipse with the major axis no longer perpendicular, but certainly in a different direction from the first ellipse. And finally, if the second cluster is very poorly separated from the first, the major axes of both ellipses will be nearly collinear. And notice also that the ellipse for the second cluster is more like a circle because it's less well defined.